and these are metacarpals. I just figured I'd teach you a little anatomy and geometry. Anyways, today we're going to be going over some postulates and theorems, and these are going to be pretty basic ones that you probably already figured out anyways, but we're going to go over them. So postulate 5 says, there's a lot to postulate 5. A line contains at least 2 points. So here's a line and here are 2 points. So there have to be 2 points in every line at least. Okay? There could be several points. We could have A, B, C, D, E, F, G, H, I, J, all the way up to K, whatever. Or at least 2 points. And if you draw any 2 points, I need chalk. If you draw any 2 points, you can always make a line through them. Right? A plane contains at least 3 points, not all in one line. So these beautiful drawings drawn by Nico himself. Here's a plane, and it contains at least 3 points, not all in one line. Okay, so there are 3 points on that plane, as you can see. So a plane, as we know, goes on. We can't see the ends of it, but when we do draw the ends of it, there's at least 3 points in there. And the last one says space contains at least 4 points, not all in one plane. So here up here is 4 points of space, and space is in that plane, and in that plane we've got the 4 points in space. Postulate 6, through any 2 points there is exactly 1 line. So we're not drawing 10 lines in the same 2 points. There's only 1 line there. You're going to see a lot of these postulates, they say exactly one and only one. They are unique. So just know that when we have 2 points, we're only going to be able to draw 1 line there. Okay? Postulate 7, through any 3 points there is at least 1 plane, and through any 3 non-collinear points there is exactly 1 plane. So any 3 points, so down here, down here. Through any 3 points, there is at least 1 plane. So we've got 3 points right here, and at least 1 plane. We can draw a plane there. And through any 3 non-collinear points, there is exactly 1 plane. And so you've got 3 points that are non-collinear and exactly 1 plane. All right, over here. Postulate 8, if 2 points are in a plane, then the line that contains the points is in that plane. So if 2 points are in a plane, these 2 points are in a plane, and the line that contains that point, the points, is in that plane. Well, I didn't go through you're saying this one?
Yeah.
Yeah, but that's not on the plane. B's not on the plane. So I'm going to go with this one because if 2 points are in a plane, then the line that contains the points is in the plane. So these 2 points, they're still on this plane. We'll call that plane M. And the lines, that's all right. No, that's fine. These 2 points are still in plane M. Postulate 9, if 2 planes intersect, then their intersection is a line. And I showed you guys that with those 2 pieces of paper that I had in class. Oh, by the way, keyword is 4 mystic lines, hashtag, like this, hashtag yams, hashtag yams. Okay. So I just got sidetracked. If 2 planes intersect, then their intersection is a line. Okay. So here's this plane and here's this plane. And we did this in class. The intersection would be a line. You've got a line right here intersecting 2 planes, and I can show you that in class again with those 2 pieces of paper, how no matter where you intersect, it's going to be a line. All right, we got 3 more theorems over here. Theorem 1-9. If 2 lines intersect, then they intersect in 1 point. Any 2 lines are going to intersect in 1 point. Just like that. So if I went like that, and then I went like that again, we could say the lines intersect in each other, but we've already said by that postulate over there that only 1 line intersects in 2 points. So if 2 lines are going to intersect, no matter where they are, in these 2 lines, it would be right there. Okay. Theorem 110, if there is a line and a point not in the line, then exactly 1 plane contains them. If there is a line and a point not on the line, then exactly 1 plane contains them. So here's plane Q, and we have a point on this line, and point B is not on the line, so that's just one plane that contains them. They're not off on some other plane. Finally, theorem 111, if two lines intersect, then exactly one plane contains them. Okay, so here's the two lines that intersect, and we have exactly one plane that contains them. There might be other planes up here, but for these two lines, this is the plane that contains them. All right, so go off and do your classroom exercises and have fun, and thank Nico. Thank you, Nico.
I got poop. Ew.
He's got a hair in his mouth.
Ew,
Gross.
it's from Kelly.
All right.